Thank you. I think you can hear me. Thank you for attending this session. As anticipated, my name is Guido Nebbiolo. I work for Reply. We are a system integrator. I lead a group of people focusing 100% on generative AI and AI. But I think all of you are here not to listen me talking about me, but to talk about an important design choice that many companies are facing as they adopt generative AI. The question is how to select the right approach when integrating AI-powered workflows in real-world systems. Depending on the complexity and the requirements of the task, we might design our system with several different paradigms. We may simply use function call within LLM. We may deploy a single autonomous agent, or we may orchestrate multiple agents working together. Each approach offers distinct benefits and trade-offs, and as generative AI adoption expands across industries, making the right architectural choice becomes increasingly important for performance, safety, and especially for business value. Let's start with the simplest approach, function calling. Modern LLMs, like the models that are available on Bedrock, can interface with external systems through function calling. It's a feature that is new because it allows developers to define APIs and functions that an LLM can invoke when needs to access external data or do calculation or things with the code. Instead of generating free-form text, like temperature tomorrow should be around 25 degrees, the model can call a function and get the result and get back the exact value. This is a game changer for reliability because structures and deterministic outputs are replacing the unpredictable text generation. Makes AI safer to integrate into real-world business workflows, and you can fetch live data, perform calculation, retrieve inventories, check customer balance, verify booking details, all of it with a deterministic external function call. For example, think of a banking assistant. When a customer asks, what's my current balance? We don't want that the model guess the answer, but it simply triggers a backend function and can retrieve the exact value from a customer database. Function calling is essentially the bridge between probabilistic reasoning, typical of LLM, and the deterministic words of software APIs. Let's now bring to a concrete travel scenario. Imagine I need to plan my trip to reInvent in Las Vegas for next week. I will start prompting an LLM asking, next week I will go to Las Vegas for a few days trip. What do I have to put in my luggage? And a standard LLM would give a generic list of clothes, generic list of jackets, sunglasses, things like that, without taking into consideration that when I say it next week, is already providing a lot of information, like season, like things that I really need to do and to bring with me during my stay. Now, if I equip the model with function calling capabilities, it can enhance the generation of its answer. The model says that so that my request involves the place and the date, and can call that function to get something specific for that specific moment. And with this real forecast, can now say the real things that I need. The result is far more accurate and personalized. Here is an example of doing function calling with Bedrock. It's pretty simple. Essentially, we put inside the definition of the prompt, even the tool that the LLM can access. Function call is extremely efficient, but only for known and simple interactions. Once we scale up to real-world scenario, we have enterprise workflows with dozens of tools, interdependent functions, more dynamic requirements, and things get harder really quick. The more functions involved, the more back and forth between the LLM and the application we have. So the system still needs to hold the business logic and act with this back and forth with the LLM. At this point, we start using reasoning inside the AI itself, and this brings us to agent. The React pattern that it's reasoning and acting showed us that an LLM can do more than just predict text or call function directly. They can reason. For example, first I need to check specific things. Then, depending on the result, I will call another one. And just like humans, essentially thinks on how to solve a problem. By integrating this tool description into a prompt, the model can dynamically choose which tool to use, also plan multiple steps ahead, and analyze the intermediate result and adjust the action accordingly to the result it obtains. This allows us to build a system where AI is not a passive responder, but it actively drives problem solving. And this leads us directly into an agentic architecture. An agent is a step beyond function calling, I would say. It's an autonomous AI process that essentially receives a goal, reason on how to solve it, decompose into this task into multiple steps, and decide when to call function, when to use tools, when to fetch external data. Let's see in practice. Let's see the scenario that we had before. Imagine we want to extend that scenario. In this scenario, instead of simple calling a single get weather function, we want a system that is autonomously able to handle multiple aspects. For example, retrieving the weather forecast, checking the hotel availability, verify the flight to come here, and even suggest activities depending on the length of my stay and the season in which I am. The agent is initialized with multiple tools, a weather API, a flight search tool, an hotel booking tool, maybe even integrated with my calendar to check the things that I have scheduled. And the key difference here is that we no longer manually orchestrate the different steps. An agent is able to reason step by step, deciding when to invoke each tool and whatever is needed during the evolving of the understanding of the problem. For example, say that we want to plan this 5 trip to Las Vegas next week. The agent can decide to call the different tools to have information about the weather, to check the availability of flight and hotels, and even querying the weather forecast for those days, finally recommending the things that I have to take. Sometimes one agent is not enough. Some business problems are more complex and need to be break them into specialized roles to deliver better results. This is where multi-agent system comes in. Instead of one single agent juggling between different domains, we can create multiple agents that can collaborate. Each one can be focused on a particular area, having its own expertise, its own dedicated tools, and its own dedicated instructions. Continuing at the travel scenario, a little bit further, we can have a weather agent focusing purely on forecasting, the flight agent focusing on the flight searches, the hotel agents for the accommodations, the activities agent that suggests all the things that we can do during this period. And sitting on top, we can have a coordinator agent that essentially orchestrates all of them. Each agent can work independently and efficiently, staying in the boundaries of its own domain, improving accuracy and modularity. In this example, if we can improve a single agent without touching the other and without the risk of breaking things that are working, this resembles how human organizations are working. Different specialists that collaborate through a manager. Before diving into challenges, let's look at two foundation multi-agent architecture that you can choose from. The first one is the hierarchical pattern, also called supervisor. In this pattern, we have a central orchestrator that we can call supervisor that breaks down the overall goal into different subtasks, distribute them to the specialized worker agents. Each worker is focusing only on its own domain without calling with the other. The supervisor collects and consolidates all the results. This approach provides clear control on who is in charge of what, easy debugging, and straightforward sequencing of the different actions. The second one is the network, also called swarm. Here we have multiple agents that can operate as peer in a mesh with a shared blackboard. There's no single boss. Instead, we have agents that communicate directly to share information, to coordinate the different tasks. This pattern offers more resiliency, obviously, because if one agent fails, the others can continue to work. But on the other side, enables also parallel problem solving, but can be very complex to manage. Once wiser than me once said that with great power comes great responsibility. We have challenges, obviously, with multi-agents architecture. There are several challenges. The first one is the orchestration complexity. Who can talk to whom, when, in what order? The second one are latency and costs. Multiple agents means more LLM calls. More LLM calls, more tools, potentially longer response time. Third one is debugging. As a distributed system, if something goes wrong, we need the detailed observability, tracing the full chain of agent decision across the different agents. And last but not least, we have security and safety. Each agent can access different sensitive data, and permission must be carefully controlled in a way that all the agents stays in its own boundaries. Imagine real-world failure. We can have two agents, one calling each other recursively, endlessly, because of a misaligned prompt, or a tool API that has been changed without notice, bringing the agent unable to call that specific function call. No one notices until the user complains. That's why strong observability and monitoring, like for example using strands with OpenTelemetry, it's crucial when deploying multi-agents architecture. When choosing between function call agents and multi-agents architecture, it's not about picking the most advanced option, because it can be difficult to manage it. It's about selecting the right level of intelligence and autonomy that we need for our use case. The first things that we have, the first key driver, in my opinion, to take into consideration is the task complexity. This is about how many steps, how many moving parts are in our problem. It's a simple question-answer flow that the user asks, or multi-step tasks are evolving using the context. If the task is pretty straightforward, function calling is enough. Quicker, easier. If it involves multiple subtasks, contextual interpretation, chaining decision, maybe an agent, like for example the example of booking a travel, an agent can be a good choice. And when instead a task involves parallel domains, like for example legal, compliance, and finance in the same problem to solve, and requires coordination, multi-agent system is usually a better fit. The second one is predictability versus adaptability. The question that we want to answer is how tight do we need to control the system behavior? Or we prefer that it adapts in some open-ended way to solve the problem that we gave us. Function calling offers full predictability. It's a single shot. The LLM suggests a function, the system executing exactly as needed, and gave the result for deterministic control. Then we have agents, which gives more adaptability. Essentially, they decide dynamically which tool they need to use based on the user intent and the evolution of the context, the evolution of the problem solution. And then we have multi-agent system that allows emergent behavior. Essentially, agents may solve sub-problems differently based on their domain knowledge. This is very powerful, but obviously less predictable. And that's where a good observability becomes critical. The third one, it's cost and latency. When you prefer performance or budget? Where are your constraints? Essentially, do you need a very responsible system, or you can live with a system that solves the problem in a synchronous way? Function calls are cheap and very fast. Minimal token use, few model calls. Agents are more expensive. They often reason through multiple steps to solve a problem. And multi-agent system multiply cost and latency, obviously. Then we have control over the business logic. Essentially, who defines how the system behaves? Are you, or the model itself. With function callings, you control everything. With agents, the logic is partially embedded into the prompt and the reasoning steps that the LLM do. And with multiple agents, you are essentially delegating everything to them to solve the problem in the way that they think it's right. And last but not least, we have the autonomy. How much initiative should the AI take? Function callings are reactive. The LLM says, the user asks something, the model responds. Agents are instead proactive. They can decompose goals, decide the different steps that they have to take, and ask even follow-up questions if needed to solve the problem. With multi-agents, we have a collaborative and autonomous view. Essentially, they can assign roles between them, distribute the task, and solve the problems with minimal to no human input. A recap table to visualize it. Essentially, low complexity and low autonomy, obviously use function calling. Moderate complexity and adaptive reasoning. Here, you can use a single agent. And high complexity with multiple domain collaboration, multi-agent orchestration. For example, let's think about retrieving a product price. Retrieving a product price is a simple function calling. No, we don't need any more complex than that. For planning a vacation, using a single agent, it's a single domain in which the agent has different tools, different API that it can call, and can decompose the problem, staying in the boundaries of the domain. And instead, building an enterprise legal advisor obviously involves multiple tasks between different domains, and that's where multi-agent system can act. Let's map some real-world use cases. Function calling, you say, for example, FAQ bot, currency conversion, all the things that can be solved very simple, order status lookups. Then we have agents. With single agents, we can say that we can have a travel planning assistant, personal research assistant, content summarization, the typical assistant that you are using in your everyday job since some years. With multi-agents, instead, we have use cases like complex contract generation, enterprise-wide troubleshooting, even project management or legal due diligence can be performed by multiple agents put in the same solution. The thing is, the more ambiguity, the more specialization or collaboration the problem involves, the more an agentic approach helps. The more less specialization, more we are more helped by function calling. Let's wrap up. First things, always start simple. Don't overcomplicate the problem. Use function calling whenever deterministic output is sufficient. Or you can use single agent for multi-step tasks that need adaptive reasoning. And use multi-agents when you need different domain specialization and complex workflows. Second thing is always plan for observability. Things will break, definitely, using LLMs. Always plan for observability, for cost control, and especially for governance. And the third one, last one, remember that AWS provides different end-to-end tools that we can support the Korean user for supporting at every level. We have Amazon Bedrock, Lambda, Strands, step functions, even Agent Core. All these services can be used to build an agentic AI solution. I hope this gave you a clear model on how to apply AI inside your project. Here is my contact. Feel free to get in touch with me. Remember to leave a feedback of this session through the mobile app. Thank you for your attention.
Thank you so much.